For problem 25, a chord 8 inches long is 3 inches from the center of a circle as shown below. What is the radius of a circle to the nearest tenth of an inch? So this is one of those problems where you need to know that if you draw a chord inside a circle, so it's going from one side to the other, every time they say that it's a certain distance from the center, it means that you're going to have a perpendicular line here measuring whatever they said. So in this case, it's 3 inches. And it's important to know that this is perpendicular because then everything else follows. Since this is a line perpendicular to the chord, if the entire chord measures 8, that means that cutting it in half, you end up with segments of 4 and 4. So you end up having a right triangle. This is, of course, 90 degrees. We already saw that here. And one of the sides measures 3 and the other one measures 4. And you want to know the hypotenuse, which is a radius. And this is one of those neat, very neat triangles that has a 3, 4, 5 measurement. The hypotenuse is 5, is a nice whole number, and the sides are 3 and 4, respectively. If you don't know that special triangle, you can still figure it out using the Pythagorean theorem that says that the sum of the sides squared, or the square of the sides, should be equal to the hypotenuse squared. In this case, 3 squared is 9, plus 4 squared is 16, and this will be the radius squared. So 25 is the radius squared, because the radius is the hypotenuse. Now, we don't want to know the radius squared, we want to know r, the radius. So we need to take the square root of both sides, and so the radius is equal to, of course, 5, which is choice C. For problem 25, once you know that if the chord measures 8, so the other side of the right triangle will measure 4, that means that you have a right triangle measuring 3, 4, and r is the hypotenuse. So again, the Pythagorean theorem, the square of the sides, the 3 and the 4, squaring, added, will equal the square of the radius. And so if you don't know that special right triangle, which is a 3, 4, 5 right triangle, you don't need to memorize it. Again, you would just key in parentheses 3 squared for one of the sides squared, plus the 4 squared for the other side. That's, of course, equal to 9 plus 16, which is 25. Now, that's 25 corresponds to the square of the radius in this case. So we need to square root it to find the actual value. So the square root symbol, again, we use the second key in x squared. We can use the answer key or just key in the 25. And again, of course, 5 is the answer, choice C. For problem 26, the length L in meters of a spring is given by the equation L equals 2/3 F plus 0.05, where F is the applied force in newtons. Approximately what force in newtons must be applied for the spring's length to be 0.23 meters? So you need to be able to plug in correctly, and when you use the TI or your calculator, to use it correctly, otherwise you're going to end up with some mistakes there. So essentially, the length needs to be 0.23 meters. So that's L. So we replace L with 0.23 meters. Now this is equal to 2/3 times F the force plus 0.05. I'll just put 0.05. Now to solve for F, which is the force we're looking for, we need to first subtract the adding 0.05. So it's adding on the left side, on the right side, we'll send it to the left side subtracting. So we end up with 0.23 minus 0.05 is equal to 2/3 times F. So 0.23 minus 0.05 is equal to 0.18. 0.18 is equal to 2/3 times F, the force. At this point, what you want to do is solve for F. So notice how 2/3 is in a parentheses and it's multiplying F, the force. Well, you can get rid of it from the right side and solve for F by sending it to the other side, dividing, because it's multiplying the F on the right side. So that leads to 0.18 divided by parentheses 2/3 is equal to F. Now, what's interesting is that if you're comfortable enough realizing that a fraction like 2/3 is just a number, So it doesn't matter if you had, say, 5f, you would divide by 5. In this case, it's 2/3 times f, so you send the 2/3 dividing to the other side. If this confuses you, well, just let the calculator figure it out. But it's very important how you enter this into the calculator. You would want to enter it as 0.18, then divided by, open a parentheses, and just key in 2 divided by 3, 2/3. And when you press enter on your TI, you'll get the right response. In this case, 0.18 divided by parentheses 2 divided by 3, close parentheses, is equal to 0.27, which is the force in newtons. And so that would be... For problem 26, since they're telling you that the length has to be equal to 0.23 meters, what we can do is we can key in 0.23 for the length and then subtract from that minus the 0.05 that was part of the equation that was on the other side adding. So you send it to the left side with the L subtracting. So that gives you 0.18. Now 0.18 is equal to 2/3 of F, the force, which you're trying to find. So the 2/3 needs to go to the left side with this 0.18 dividing. Now look how easy this can be done with a TI. You simply key in 0.18 divided by, open a parentheses, because you're going to divide that value by 2/3. So just key in 2/3. You don't even need to use the frac key for fraction. You can just enter it like that, and it will give you the right answer, which is 0.27, which is choice K. Of course, instead of a 2/3 like this, you could have actually entered a properly in fraction format. So you could have done 0.18 divided by, and then you go to math, scroll over to the fraction, and then choose the 1, numerator, denominator. So there's your fraction, and you're going to be dividing by, again, the 2/3 that was on the right side, multiplying the F, the force. And so 2/3. Notice how we're going to get the exact same answer that we got here above. So two different ways of getting the answer in the TI for this prompt. Why did I use parentheses here? I just want to make sure whenever I enter things on my calculator that if this is my numerator, 0.18, divided by my denominator, I rather just keep the denominator and the numerator even in parentheses set, so that I'm guaranteeing that the calculator will do the operations in the right order. So in this case, it first divided 2/3, and then whatever answer it got, which is 0.66666, it did 0.18 divided by that. So 0.18 divided by 0.66666, etc., is a 0.27. Why am I getting something here? Because 2/3 is not actually equal to this. There's a lot more sixes here. In fact, it's an infinite number of sixes next to each other. 2/3 has an infinite decimal part that is repeating. So that's why we're getting this slightly different result. For problem 27, it reads, after a snowstorm, city workers removed an estimated 12,000 cubic meters of snow from the downtown area. If this snow were spread in an even layer over an empty lot with, I mentioned, 62 meters by 85 meters, about how many meters deep would the layer of snow be? So quickly, this is what's happening. First, we have a 12,000 cubic meters of snow. In other words, this is a volume measurement. So we know that we have this amount of snow somewhere. And they're asking us if we were to spread this evenly in a lot that measures 62 by 85. So let's say it's something like this. So this is 62 meters and this is 85 meters. What would be the depth of the snow? So we would end up with something like this. So we're transferring this amount of snow and distributing it evenly into this lot. So first thing we want to know is, what is the area of this lot? And fortunately, everything is given in meters, meters, and cubic meters, so we don't need to convert. So the starting point is to figure out the area of this lot. So we want to know what the area is. So we do that, we find that by multiplying 62 times 85, which gives us 5,270 square meters. Now, notice that we have a total of 12,000 cubic meters, and we want to see how deep it would be spread evenly over an area of 5,270 meters squared. So if we divide 12,000 cubic meters by 5,270 square meters, and look what happens to the meters. We end up with a meter measurement because we have 3 cubic meters in the numerator, and we're dividing by square meters, so that leaves us with meters. And it's precisely the measurement that we need. We want to know how deep the measurement of this, once you spread the snow evenly. So keying in 12,000 divided by 5,270 gives us an answer of approximately equal 2.27 meters. So that's how deep it would be. And clearly, choice C between 2 and 3 is the correct. So for problem 27, we first need to know what the square footage is of that lot. So because it measures 62 meters by 85 meters, 62 meters by 85 meters gives us 5,270 square meters. Now the snowstorm, after the snowstorm, city workers removed an estimated 12,000 cubic meters. So essentially what you want to know is the 12,000 cubic meters divided by the 5,270 square meters will give you the depth of that snow once you theoretically put it in that lot. And so the depth will be in centimeters, in meters, 2.27 meters. So that's why choice C is correct. How many meters deep would the layer of snow be? Between 2 and 3. Between 2 and 3. For problem 28 reads, the hypotenuse of the right triangle LMN shown below is 22 feet long. The cosine of angle L is 3/4. How many feet long is the segment LM? So 2 ways of doing this. One, you can use your knowledge of geometry. So you also need to combine that with trig, knowing what the cosine of an angle is. So remember that the cosine of an angle, in this case L, is going to be equal to the adjacent side to the angle L divided by the hypotenuse. In other words, in this case, they're saying that cosine of L, which is this angle right here, is equal to the adjacent side, which is segment LM, the one that we're trying to find the measurement of. So LM divided by the hypotenuse, which in this case is 22. Now, if the cosine of angle L is 3/4, we are allowed to do something interesting here. We can say cosine of L, which is equal to the segment we're trying to figure out for, divided by 22, but we know that this is equal to 3/4. So, because when we're working with trig functions and right triangles, we're always using triangles that are proportional to each other, we know that 4 would be the 22 and 3 would be the segment LM. But that would be the smaller proportional triangle to the one that we're actually dealing with here, which is a 22 by x, or 22 by the segment LM. So we can use the ratio here, LM divided by 22 should be equal to 3/4, and solve for LM. We achieve that by multiplying both sides by 22. So the segment LM is going to be equal to 3/4 times 22. Now this is equal to 0.75 times 22, which is of course equal to 16.5, which is choice G. Now the other thing you could have done is the following. Well, if you know that the cosine of angle L in this case is equal to 0.75, because that's how much 3/4 is, then you simply do the following. You say, okay, cosine of L, which is 0.75, is equal to the adjacent side, which is the segment I'm after, divided by the hypotenuse, which is 22. Solve for Lm. Send it 22, that's dividing, to the other side multiplying, so you got 22 times 0.75, and this should be equal to the segment Lm. So when you multiply 22 times 0.75, you again get the same 16.5 we found before. So two ways of solving this problem. Either way, I personally feel that this is the simpler method, as long as you know what a cosine of an angle is. And again, let's just quickly review sine, cosine, and tangent of any angle. So sine of an angle, any angle, is equal to the opposite side of that angle divided by the hypotenuse. Cosine of an angle is equal to the adjacent side to that angle divided by the hypotenuse. And finally, the tangent of an angle is equal to the opposite side to that angle divided by the adjacent side to that angle. So it doesn't matter which angle you're talking about, you just need to be careful that you know which one is the opposite side or the adjacent side to that angle. And in this case, we were working with L, which meant that the opposite side would be segment MN. This is the opposite side. And then the adjacent side to that angle would be segment LM. This is the adjacent side to angle L. It would be different if we had, say, used angle N, if they had told us the measurement of the cosine of angle N. In that case, the adjacent side would have been segment MN, and the opposite side would have been segment LM. So it is important that you always consider which angle. One way in which you can find the answer to 28 with the TI, because the cosine of an angle is equal to the adjacent side divided by the hypotenuse of the angle. In this case, the adjacent side is the segment LM they're asking us to figure out. Because the cosine is 3/4, well, 3/4 is 0.75. So the equation would look like this. 0.75 is equal to the adjacent side divided by the hypotenuse. But the hypotenuse is 22. It's given on that prompt. In other words, 0.75 is equal to the adjacent side divided by the hypotenuse, divided by 22. So because the 22 is dividing and you want to solve for the adjacent side, because again, the adjacent side is the segment LM they're trying to get you to figure out, you send the 22 that is dividing on the right side, multiplying the 0.75 that would be on the left side. So if you multiply 0.75 times 22, you get the right answer of 16.5. So that's one way of solving this prompt. And again, you need to know trig functions for that. The other thing you could have done is simply, because triangles are proportional, and when you use sines and cosines and tangents, etc., when you talk about the sine of the cosine of angle L is 3/4, you can say that it measures 3, the adjacent side, and 4, the hypotenuse. But in this diagram, they're giving us a triangle that measures 22 for the hypotenuse. So you have a proportionality there of 3/4 is equal to x divided by 22. So because you want to solve for x, you would multiply 3 times 22, and then you would divide that by 4, and that gives you the same 16.5 answer. So both involve using trig functions and knowing that what trig functions stand for. And then you could do it, using either the idea of proportional triangles from geometry, which was this method right here, or you simply solve the equation, which was the first method we used here.